So by this point, students should have had plenty of experience working with the materials and should be well on their way to abstraction. In fact, they've probably tried to do a lot of the work just mentally, or maybe they've been drawing pictures to kind of get them started. That's really where we want them to be at this point. And of course, if students are already doing this way, then they can just give us the answer. They can summarize what they're doing for us, and then we can just move on from there. So this will be completing the square towards abstraction. So you've been practicing completing the square for a while now. Let's talk about what you might have observed. Let's look at our old friend x squared plus 6x plus 7. Now you know you're going to have to make a square out of this, right? So what do? Well, we know that to make the square, we're going to have an even number of x pieces on the left and the right. So that means we're going to take this 6x and we're going to split it into 2 equal pieces. So that gives us 3 over there and then 3 over there. And then we try to fill in what we have blank in this corner down here. Now, we know that we want 9. We know that we want 9 because we had sides of 3 and we want to square that, but we only have 7. So that means that since we only have 7, we're going to need to get 2 more. We can make our 0 pairs then. And then we see that we have x plus 3 squared minus 2. So what's the key to this work? The key to this work, unlike when we factored and the key was those units, here the key is really that x term. That x term determines the size of the square. And the size of the square is always going to be half of whatever that coefficient of that x is. So when we had x squared plus 6x, it didn't really matter what that number was at the end. We knew that we wanted 9, because half of 6 is 3, and 3 squared is 9. What would we want that last number to be to complete the square in this example? Here we have x squared plus 8x minus 10. We can start by asking ourselves, is this a perfect square trinomial? And the answer is no, it's not. And why not? Because this last number isn't a perfect square, and it's not the right perfect square. So we have to ask ourselves, what would the right perfect square be? And we can imagine that if we had our x squared, we're going to split that 8x into 4 and 4. In other words, we're going to take half of it. And that's going to determine how many units we want. So half of the 8 is 4. 4 squared is 16. So we really want 16 right there. And so that's really what we want to be thinking about when we're completing the square, is what do we really want for those units? And the x's determine that for us. So when we want to complete the square, let's just think about what's important. We've made our frame of x squared plus 8x, and then this minus 10, we just don't want that. We actually want 16 here. So we don't even care about this minus 10, so I'm just going to get rid of it. I'm just going to push it over to the side, and we're going to do the same thing with our writing. So we had x squared plus 8x minus 10, and so now I'm going to literally just move that negative 10 off to the side. I don't even want to think about it or deal with it. We can just ignore it for now. Instead, we think, what do we want to have here? Well, it's going to be half of 8, which is 4, squared, which is 16. So we're going to put 16 units to complete our square right here. And so with the writing, we just added the 16 to this group over here, this x squared plus 8x plus 16. Now, we also know that when we add 16, we're going to have to make our 0 pairs. And so we're just going to take this negative 16 that comes along with adding those 16 here, and we're just going to combine those with our negative 10. So that's going to make us write negative 16 right here. So this is the 16 we added to complete our square, and then this is the negative 16 that made our 0 pair so that we could complete the square. And now what do we have? Well, we see we have the x plus 4 squared right here, so I can do that in the writing. And then to see what I have on the right, I just combine these together. And that gives us negative 26. And so that's the way that we can complete the square without trying to do that mental math. And yes, we can do it, but this technique will get you there without having to worry about is it positive or is it negative or how many do I add? So just to summarize, what we did was we took that number of units and we just ignored it. We just pushed it to the side and then thought, what would I really want that number to be? What would make that a perfect square trinomial? Then we just simply added that number in, and then we added the opposite of it for the zero pair, and then we just read what we had. So go ahead and try that technique as you continue to work with completing the square and see if that makes the work a little bit simpler for you. That technique of ignoring those original units and thinking about what do we want to have for the units there, that technique is going to be really helpful in the writing. That's going to be the cleanest way for students to complete the square to solve equations or to rewrite, to put things in vertex form, or anything else that they need to do for completing the square. So we do want to show that technique to the students, even if they do have their own techniques that might be slightly different. If they want to use their own techniques, that's fine. As long as they can do it efficiently and do it accurately, then there's no problem there. So we can show this as an option for students to use, and I think they will find that it's going to be pretty efficient. And it's also something that's based on previous student knowledge. So it's not as if we're giving them something that they haven't discovered on their own. And so we wouldn't want to do this lesson until students feel pretty comfortable with the process and understand what it is that we're doing. As students do this work, they should also be articulating what they're doing. They can be doing the work in drawing and writing about what it is that they're doing and why. And that really helps to solidify that process. There's also one more exercise that we could give students to do at this point to see if they really understand the process. What we can do is we can give students something like this to complete the square with, where B and C just stand for any numbers. And this really helps students focus in on what is it that I'm doing, not so much what are the numbers, what's the answer. They have to think, what is it that we do? And so for here, what they do is they say, well, I don't want that constant. That's a constant that probably is not going to work, so we'll move that to the side. And then we have to fill in the square here. How do we get that number? We take half of this number and square it. So that means we're going to take half of B, whatever number that would be, and square it. And then we have to make a zero pair with that. So we're going to subtract that away. And then we read the square that we have here. And this looks really complicated to try to factor this, but they should know what it's going to be. It's always going to be x plus half of whatever b is, quantity squared. And then they combine these together here. And so when they combine these together, they have to do a little bit of work with fractions and squaring and order of operations. But they could leave it as it is, or they can practice with that and get this for the final answer here. And you can see this might lead us eventually into the quadratic formula, and this is practice for that technique later. But for now, what this really is, it's a way for them to articulate what it is that they're doing, and the symbolism helps them along that process. So giving them an exercise like this to do as a culmination of their work can really lead them to further work, but also solidify the work that they've been doing and help them on their way to abstraction.